Welcome back to our channel, viewers. How do we determine the red area in this radical geometry problem? Now for the start, let's go to the whiteboard. Now how do we determine the red area? So we'll start by analyzing this diagram. So you see we have a triangle ABC, which is a right angle triangle at point C, where we have the 90 degrees and we have the inscribed circle. So the inscribed circle, we have 3 tangent points. So this tangent point, we can let it be to be point E. Then we have this tangent point here, we can let it to be point F. Then we have this tangent point here, we can let it to be point G. Now you know that any two intersecting tangents are always equal. So if you see from G to C is a tangent. So if you let it to be X, it is intersecting with the tangent FC. So it means FC will also be X. Intersecting tangents are always equal. So if from F to C is X, then it means from F to B will be 30 minus X, because from B to C is 30. So if from F to C is X, then from B to F will be 30 minus X. So you see the tangent BF is intersecting with the tangent BE, so they must be of the same length. So if B to F is 30 minus X, then B to E will also be 30 minus X. So if from A to B you are given to be 34, and from E to B we found is 30 minus X, then it means from E to A will be the whole length, which is 34 minus 30 minus X. So 34 minus 30 minus X, you get 34 minus 30 is 4, then negative into negative is plus X. So if the length of the tangent E to A is 4 plus X, then the tangent G to A is also 4 plus X, because the tangent AE is intersecting with the tangent AG. Intersecting tangents are always equal. Now that we have found all lengths, the first length, this length from B to C we have is 30. Then this length from B to A we've been given to be 34. Then the length now from A to C is 4 plus X plus X. So X plus X will be 2X. So it means the whole of the length from A to C will be 4 plus 2X. Now we can actually use the Pythagoras theorem to determine the value of X. So if you take the triangle ABC, so taking triangle ABC, the longest side is AB, so we'll have the hypotenuse squared is equals to AC squared plus BC squared. So AC squared plus BC squared. So if you substitute from A to B, we have is 34. So there we have 34 squared is equals to, from A to C is 4 plus 2X. So that is going to be 4 plus 2X squared, then plus from B to C. From B to C we were given to be 30. So plus 30 squared. So if you collect the like terms, 30 squared coming this side, we will have 34 squared minus 30 squared is equals to 4 plus 2X all squared. So 30 squared minus 34 squared, that is a difference of 2 squares. When you have A squared minus B squared, that is going to be A plus B into A minus B. So 34 squared minus 30 squared is going to be what? That is going to be 34 plus 30 into 34 minus 30, which is equals to 4 plus 2x squared. That is a quadratic identity. If you expand, you get 4 squared will be 16 plus 4 times 2x is 8x times 2, that is plus 16x, then 2x, if you square you get 4x squared. So if you simplify this, we get 34 plus 30 is going to be 64. Then it is times 30 minus 34 minus 30 is 4. Then the whole of that is what is equals to 16 plus 16x plus 4x squared. So what do we have? So we have on this side of the equation, we have 64 times 4 is equals to 4x squared plus 16x plus 16. So we can divide all through by 4. It's a common factor. We can divide all through by 4. So if we divide all through by 4, this 4 will go with that 4. This 4 will go with that 4. This 4 will go here 4 times. 4 will go here once. 4 will go here 4 times. So we'll remain with 64 to be equals to x squared plus 4x plus 4. So we found 64 to be equals to x squared plus 4x plus 4. So we can subtract 64 on both sides of the equation. So we'll remain with 0 is equals to x squared plus 4x plus 4 minus 64 is minus 64. So this is a quadratic equation. So if you solve x squared plus 4x minus 60 to be equals to 0, that is in the form ax squared plus bx plus c to be equals to 0. So from there you can see a, the coefficient of x squared is 1, b, the coefficient of x is positive 4, and c, the constant term is negative 60. So if you key in the value of a, b, c in the quadratic formula, what do we have? We go to the quadratic formula. We have equations number 5, then quadratic equation number 3. Then we key in the value of a is 1, the value of b is 4, and the value of c is negative 60. So if we solve this, what do we get? So we get the first solution of x is 6, the next solution of x is negative 10. So because x is a length, we are interested with the positive solution. So we found x is either 6 or x is equals to negative 10. Because x is a length, x is equals to negative 10 is out. So x is equals to 6. So where there is x, we will substitute with 6. So we found this x value is 6. So it means this length here is 6, this length is 6. Here we add 4 plus x. So 4 plus 6 is going to be 10. Then 30 minus 6 is going to be 24 in that order. So when you substitute, what do we now have in the diagram here? The value of x. So from a to g is 10, meaning this length is also going to be 10. So having done that, so how do we get the area of the red region? Now getting the area of the red region is very simple. Remember from C to G was x, we found to 6. From A to G we found is 10. So 6 plus 10, it means the whole of this length is 16. From A to C is 16. Then from B to C is 30. So it means we can get the area of the right angled triangle. So what we need to get is to subtract the area of this small triangle AEG. Remember, this was point E, this was point E. So we subtract the area of this triangle AEG. So if we let this angle here to be angle theta. So let us start. What is the area of triangle ABC? Triangle ABC, the area is very simple. That is just a half base times height. So you get base times height divided by 2. Base is from B to C, which is 30. Then it is times height from A to C, which is 16. Then divide by 2. So you get 30 times 16 divided by 2. So 30 times 16 divided by 2 is 240. So it means this area is 240. Then now what is the area of the smaller triangle, triangle AEG? How do we get the area of triangle AEG? So the area of triangle AEG is going to be a half AB sine theta, where the A and B are the two sides and theta is the included angle. So you can see the value of A and B are both 10 and 10 because they are intersecting tangents. So what do we get there? We have a half times A is 10, B is 10. So that is just like 10 squared. Then sine theta. What is sine theta? Sine theta because triangle ABC is a right angle triangle, sin theta is always opposite over hypotenuse. So what is the opposite side? The opposite side is from B to C, which is 30, over the hypotenuse is from A to B, which is 34. So it means sin theta is 30 over 34. So where there is sin theta, we are going to put its value, which is 30 over 34. So what is the area of triangle AEG? 34. And you get the area is 750 over 17. So that is 750 over 17. Now if you are now looking for the red area, so the red area is now very simple. It is the area of the whole triangle ABC, which we found to be 240, minus the area of this small triangle AEG, which we found to be 750 over 17. So what is the red area? So the red area is 3330 over 17. So the red area is 3330 over 17 units squared. So you can. Thank you for watching and see you again in our next presentation. Don't forget to subscribe.